Good morning. So we have an intro lesson here. I just want to stress for students that have been not listening through, you must listen to the video too. All right, so we are doing an intro lesson today. We are introducing some really complex topics and some really critical ones as you move on in mathematics. We're introducing domain and range, inclusive versus exclusive, discrete versus continuous, as well as infinity. So please make sure that as we go through this lesson, you know that this is an intro lesson. You're not supposed to be an expert by the end of it, but we want to get started on so we can build these concepts over time. Oops, I don't, yeah. All right, so this lesson is we're going to add on an application where we look at different tax types, different tax policies, lump sum tax, flat tax, progressive tax, but we're going to save this for the next follow-up. So don't worry about that. But we are going to go ahead and jump into domain and range. So we're gonna save that analysis for later. All right, domain and range are one of those things that will click in time, but it can be a little confusing the first time we see it, which is why we need to be exposed to it all throughout our math career. So domain, I'm going to be using green for domain today. Domain is all of the x values, and remember that those x values are also our inputs. So when we think domain, we want to think x, we want to think input, and I want to add, you want to think the x-axis. When we think range, we want to be thinking about the y values, and those are the outputs, and that's our vertical y-axis. So these are the associations that we want as we go forward, and we're going to identify the domain and range of this function in a couple different styles. The first way that I want to look at domain is actually in words. So we're going to add a words column here. So when we're talking about domain, we're thinking about the x values, we're thinking about the horizontal axis. So let's go ahead and label our x-axis. And what we want to do is identify all of the x values that go along with this function. So we're going to trace the values, these endpoints, back to the x-axis. So -2 is one of the endpoints. 3 is the other endpoint. And we're looking at all of the x values in between. So in other words, we're looking for x's between -2 and 3. Right? Here's our -2, here's our 3. We're looking at all of the x values in between. Those are all the x values that that little function has. The way we would write that in interval notation is we'd say we're going from -2 is the lowest x value, 3 is the highest x value, and this tells us between -2 and 3. In inequality notation, we'd say -2 is less than or equal to all the x's, right? -2 is the lowest of the x's, and all of the x's are less than or equal to 3. So again, we're focusing on those endpoints, and we're saying everything in between. I do want you to make a note that we're always going from low to high. So we wouldn't flip that. We want the low value on the left, the higher value on the right. And again, this is an intro lesson, so take what makes sense, just stick with it until it clicks for you. And now we're going to look at the range. So we know that our range is our vertical, our up and down axis. That's our y values. So let's label our y-axis. And we're going to do the same thing. We're going to trace the endpoints back to the y-axis. So here we would trace that back right there. Here's our other endpoint. We're going to trace it back. And it's really not just the endpoints, it's our farthest down and our farthest up, right? Our domain is left to right. Our range is down to up. And the lowest the graph goes is -2. The highest the graph goes is +4. So in words, we're looking at the y's between -2 and 4. The way that we would write that is the farthest down the graph goes is -2. The farthest up the graph goes is +4. Always going low to high. So x's, you're going left to right. For the domain range, you're going low to high. And the way we would write this same between -2 and 4 in inequality notation is -2 is less than or equal to all of the y values, and all of the y values are less than or equal to 4. A common way of remembering this, right, that it says, what's a way that helps you remember that domain refers to x values and range refers to y values is in the alphabet. We have D before R and X before Y. So in alphabetical order, domain is the X's, range is the Y's. Stick with it. We're going to get a couple more topics here. And remember, this is your intro lesson. You don't have to be an expert by the end of it. Let's look at inclusive versus exclusive. This might look familiar. Ooh, my voice did a thing there. This might look familiar. We've worked with open circles, closed circles before. But when we see an inclusive graph, it just means that we're going to include the endpoint. And we see that with a solid closed-in circle. When we have a closed-in circle, we use our brackets for our interval notation, or our less than equal to for our inequality notation. If it is exclusive, we're going to exclude the endpoint. We can see that with the open circle. And when that's the case, we're going to use just a parenthesis to mark the ends, or just an inequality that's not also equal to, we're not including. So let's go ahead and kind of look at how that shapes the domain and range of these two examples. So for domain, we're thinking x's, we're thinking left to right. So we're asking ourselves how far to the left, and we can see that's -1. How far to the right, and that's +2. And we're saying all of the x's in between. So how far to the left? -1. How far to the right? +2. And because those are bubbled in, because it's inclusive, we use these bracketies. In the other notation, in our inequality notation, we'd say how far to the left? -1. How far to the right? So -1 is less than or equal to, because it's included, x, which is less than or equal to 2. Now let's compare that to, before we go on to range, to this exclusive example. Here, if we ask ourselves how far to the left, we'd say, oh, how far to the left? It's still going as far as -1, but now we're not including the -1. Here, it's still going as far as 2, but we're not including it. It is still everything in between. So the way we show that is -1 to 2, right? Left to right, farthest to left is -1, farthest to right is 2. But we're going to use that parentheses instead. And that shows here they're not actually including the farthest to the left point or the farthest to the right point. And in our inequality notation, we'd say -1 is just less than x. Not or equal to, just less than. And x is less than 2, not equal to, just less than. Alright, this one is tricky with range because here we really see that we are doing low to high and not just focusing on those endpoints. So with our range, there goes some highlighters. With our range, sorry, the air system just kicked on too. We're focusing on y values, and that's our vertical axis. And for this problem, we're saying how low does the graph go? What's the lowest point on the graph? And here we see the lowest it goes is like right here. It has nothing to do with the endpoints. The lowest the graph is right here on the x-axis. So that has a y value of 0. The lowest y value is 0. And it does look like it actually touches down at 0 here. And then the highest y value is 2, and it's including the 2. And we're looking at all the y values in between. So the lowest is 0, the highest is 2, and it does touch down at 0, and it does touch down at 2. In inequality notation, just make sure that you're talking about y's here. So we'd say 0 is less than or equal to y, and y is less than or equal to 2. Now, similarly, on the other side, we see that the lowest does look like 0. The lowest y value would be 0. And the highest y value would be 2, but it doesn't actually touch at 2. So we're saying it's going from 0, where it touches down, to 2, where it doesn't. And in inequality notation, 0 is less than or equal to y, because it does touch down there. But all the y's are also less than 2, not equal to 2, just less. And the more times you see domain and range, the more comfortable you're going to be with it, which is why we're just plowing through today, and we'll look at it more tomorrow. So here it says, what does it mean for a function to be discrete? So another new word. And what does it mean for a function to be continuous? So a discrete graph, a discrete function, means you're looking at individual points. They're not connected. Or at least they're not connected all through the graph. For a continuous function, that means we have connected points from beginning to end. It's uninterrupted. I don't know if I spelled that right. You can spell it differently if you want. All right, so this is the last thing we're gonna kind of introduce here. It says for each function, indicate whether the function is discrete or continuous, and then write out their domains. So it's just asking us for domains here, which is fine. So this is what we mean by just points that are individual points that are not connected. This would be an example of discrete. You'll know it when you see it. And then here it's connected from beginning to end. So this would be continuous. It just keeps going and going and going and going and going. When we have a discrete graph, especially here where it's just 4 points, we use kind of a fancy pants notation. Try it out. It's a little bit fun, but don't stress over it. Usually when we're talking about the domain, and again, we're just talking about x's, we make a list of the x values, and we use this fancy curly Q bracket. Try it if you like it. If not, not a big deal. But here, again, we're just tracing what are the x values. We've got -1, we've got 0, we've got 1 and 2. And we just list them out. We have -1, and remember that that's 0 and 1 and 2. That's our domain. I kind of messed up that one. That one's not very cute, but you get the idea. When it's continuous, that's when we can use that interval notation or inequality notation. So in interval notation, remember we're asking ourselves how far to the left. The farthest the graph goes to the left is -1. How far to the right? The farthest to the right is +2, and everything in between. So we'd say from -1, open, not included, to +2, included. And in inequality, we would say -1 is less than the x's, not included, and x is less than or equal to 2, included. All right, I'm going to wrap the video here. We can save the rest for another day, but I'm thinking that that was a good chunk. Make sure that you don't stress out about it. Take in what makes sense, and we'll continue building on it later.